How you going, guys? Curtis from Cutting Edge Engineering. So today's job, we have a pair of D11 blade lift yokes in for repair. So the yokes are the main pivot point that connect the blade lift cylinders onto the blade and allow the blade to be moved up and down. So it is quite common for these to wear out just from general use. The main point that wears out is where the bushes in the nose cone contact the yokes, which are these two surfaces here. And as you can see, the wear is on the top of the pin on the back bearing position of the yoke. And that's generally caused from the dozer carrying its blade, so it probably does a lot of ripping. The yoke is actually forged from one piece of material, so we are going to be reclaiming the bearing surfaces that are worn out. We would never go and replace the pin because it's guaranteed to lead to a failure. If we got these yokes and they were broken or cracked in a critical point, we wouldn't spend any time on them, we would throw them straight in the bin. So to do the reclaim, we are going to be using the metal arc sprayer, but before we can set these up and start doing the repair, we need to sandblast them and crack test them to make sure they're good to go. So we're going to get these outside and get them sandblasted. And to sandblast it, we're going to be using our Rapidblast dustless blasting system. For the abrasive, I'm going to be using 80 mesh river garnet, and I'm also going to use rapid hold, which will stop the flash rusting after they've been blasted. So we've had the blasting system for a little bit over 6 months now, and honest opinions on it, it's been a really good investment for our business. It's fast to set up, easy to use, and it has increased our productivity with being able to get parts prepped for crack testing, painting, and also repair. But some of the things I want to do is build a skid so I can mount the compressor and the blasting system together, so it's easier to move around the workshop and transport. I would also like to put a cover over the two blue control lines because I can see they're going to get worn out being dragged across the concrete. And I'm also going to put safety cables on all of the air fittings, just in case the hose does come undone, it doesn't whip around. Now we've blasted the yokes back to bare metal, I'm just going to switch over to the wash mode, and this is where the rapid hold gets pumped into the system to prevent flash rusting. Righto guys, so that is the parts blasted. They come up a million times better. If I was to do this with a wire wheel on a grinder, I would be here all day, where blasting it only took 15 minutes. Now we're going to get them back inside, let them dry off, and we can crack test them. To do the crack testing, we're going to be using our Magnaflux magnetic particle tester. The areas we're going to be testing where it's most common to find cracks and fractures is the top of the pin and through these webs where it is not as thick as the rest of the material. First thing we're going to do is apply a white background, which is going to give really good contrast when we apply the magnetic black ink. So the crack testing has shown there are no cracks in either yoke. There are a few areas there where it looks like there could be cracks, but that is where I have scratched the white background with the magnet while applying it. Typically when there are cracks on a yoke, they are visible by eye, but we don't just rely on seeing them. That's why we do the crack testing, so we can be 100% sure. So even though we didn't find any problems with these, while we've got the tester out, I do have a component that I know has a crack in it. So we're going to use the Magnaflux on that to show you how it does detect the crack. So what this is a front strut rod off a 793 dump truck. This is the most critical suspension and steering component on the truck. This one is actually a write-off because it has got multiple cracks in it and they cannot be repaired. So those two bottom ones, we knew there were cracks there, but it does make it very obvious when you use a crack tester. This third one was marked and identified that there was a crack there, but I can't actually see it, so we will test it to see if there's actually a crack there. There's definitely nothing there. So on this side, we didn't detect any cracks. There is a wear line there, and that's just where the strut sits in the housing. So that's what it looks like using the system when there are cracks present. Before I set these up in the lathe, I am going to use a micrometer just to check the bearing surfaces to see how much wear there is. Because these are in pretty good condition, I'm not expecting too much wear on the larger diameter. And depending on whether it's in spec will determine whether we do a repair to that at all. So the first thing we're going to measure is a larger diameter, and it should be 177.59 mil. We've taken our measurement across the faces that will experience the most amount of wear, and it is measuring at 176.8. So that is 0.79 mil undersized. And our tolerance for that is plus or minus 0.013, so it is well out of spec. So measuring across the other way where it won't get a great deal of wear is 177.4, but that is still undersized. So we are definitely going to have to reclaim the larger diameter. Now we're going to measure the smaller one, and it should be measuring at 152.14 mil. We knew this one had a lot of wear, and it's measuring at 150.8, so that is missing 1.34 mil. So measuring across that area, it is actually measuring at 152.1, so that is pretty close to spec, but that just shows you how much wear is applied to those load points. Now that we know that both surfaces need to be reclaimed, we're going to get this set up in the lathe and get it prepped ready for spraying. So to set it up, I'm going to be putting the end of the yoke in the 3-jaw. That area there is still in really good condition, but if it wasn't, we do have a center there that we could use to set it up. We'll also be using the tailstock pretty much fully extended to reach down inside the forks and pick up that center. And I'm also going to turn the top slide so I've got clearance to machine both surfaces. Because this is a very hard piece of material and I can't run coolant on it, I'm going to run it at about 70 RPM and a slow feed rate so I don't burn up the insert. So we've done our first undercut and that's measuring at 175.5. So that's 2 mil of material we need to put back on, but we're going to spray on about 3.5 mil. So we've got enough material to machine off and achieve a nice surface finish. Now we've done our undercut, we're going to rough thread it before we move on to the next surface. Because we need a rough thread for the spray material to bond onto, I'm going to lower the center height of the tool, which will help us achieve that. So that thread profile looks pretty good. It's not as rough as I would like it to be, but it's going to be more than enough for our new spray layer to stick to. Now with that done, we're going to do the same to the smaller diameter. So as I was taking that undercut, it wasn't cleaning up as it got to that worn area. So I've had to traverse back, increase my depth of cut, and take another one. That just goes to show how hard that material is. It has burnt out the insert and we are getting bits of swarf hanging off the threads. So I'm going to go back, restart and take the cut to finish that out. Then I'll use a stainless steel brush on a grinder to remove that excess swarf. So that's this one prepped. We're going to get this out of the lathe and set it up in the Shenyang and get that sprayed before we prep the other one. Before I move it over, I am going to move the tailstock ahead of the carriage so it's not in the way while we're trying to spray. So now we've got that set up, what I'm going to do is mask it. So while that dries, we're going to get the i450 machine set up.
No, hey, for you. What's all that? It's all gone. Yes! I can't play tug of war. Come on, let's go.
So we're going to change the wire from the R20 to the R30, which is a much harder wire once it's been sprayed. So we're going to disconnect the feed from the handpiece and roll the wire back onto the reel.
Okay.
This is the first time we've used this wire, so it will be interesting to see how it sprays and then how it machines. Get rid of that curve.
Mm-hmm. Oh yeah.
So with the reels loaded, I'm going to turn on the machine so we can use the wire wizard to feed the wire through the liners to the handpiece.
That's it. And then I should see it come out there.
Is it?
Just, yep, there we go.
Come in. So we are set up ready to start spraying, but before we start doing that, I need to give it a preheat. We're at 177 already. They're even getting hot. So spraying's completed on our first yoke. We've got both of those surfaces built up. We've got about 1.5 to 2 mil material to remove. So while this is cooling down back to room temperature, we're going to get the other one prepped, ready to come over and get sprayed. Now this one's prepped and the first one's cooled down, we're going to set this up in the Shenyang and get it sprayed. Before I take this one out of the lathe, I am going to give it a wire wheel just to remove all that overspray. So the exact same process as the first one. First thing we're going to do is mask it. Then we're going to preheat it. And then we're going to spray it. So that's our second one up to the same stage. While this one's cooling down, we're going to machine the first one. So I'm going to be machining the large diameter first, so I'm going to increase the RPM to 130 and reverse the lead screw and cut towards the tailstock. And the reason for that is I have a nice open starting point and I'm not confined into a corner. So I've done our cleanup cut, it's machining really nicely, but while I'm up at this end, I'm just going to plunge in so I can remove that overspray. So I've taken my first measurement and we've got 0.9 of a mil to remove. Because this material is quite hard, I'm going to do that in a couple of passes so I don't break or burn up the insert. So on the second cut, unfortunately the insert did burn up, so I'm going to flip that around to a nice new edge and I'm going to slow down my feed rate. So because that insert burnt up, I'm not going to trust the measurement I'm going to get from that at the moment. So I'm going to take another 0.1 of a mil off this end and then I'll take a measurement. So I've just taken our measurement, we've got 0.15 of a mil to remove to bring it to spec. So I've just done our last cut and taken our measurement. We are sitting at 177.6, where the specification for this part is 177.593. So that's well within tolerance. That's this diameter done. Now I'm just going to chamfer the edges and move on to the other diameter. So that's our cleanup cut done on this diameter. We've got 0.25 of a mil to remove to bring it to spec. So that's measuring at 152.15. The measurement we were aiming for was 152.145. So that's 0.005 of a mil off that measurement, and that's well within spec. That's both diameters machined. All we need to do to finish it off is chamfer this end and do the two radiuses. So before I take it out, I am going to give it another wire wheel just to get rid of a bit more of that overspray. Then I'm going to use some emery just to polish up the surfaces. So that's our first yoke completed, except for a paint job. Now we can get this one out, get the other one set up, and get it machined as well. So that's our second one machined. Overall, I'm really happy with how that wire worked out. It machines really well, but it is extremely hard. Now that this one's done, we can get it out and go set the yokes up for painting. So to prep these for paint, I'm going to cover the bearing surfaces, cap off the bolt holes, and give them a quick wipe down. Because these will be outside on an operating machine, I'm going to put a coat of etch primer down. Now we're going to apply our top coat. It is a quick dry enamel in black, and it is the signature colour of the D11 yokes. So that's our paint job completed. Really happy with how these turned out. These look brand new. Now they're dry, we're going to get them back into the workshop and get them ready to transport back to our customer. Righto guys, so that's this job completed. This was another really good test for the metal arc sprayer. Really happy with how it all worked out. The wire was a perfect match for this style of repair and it was able to be machined. So now we know this was a successful procedure. I do have a set of D10s and another set of D11s coming in to be done. So I think I'm going to have to keep that arc sprayer around for future repairs just like this. So that's going to be a very significant investment for our business, but this is a very economical way for our customers to get their repairs done. To replace one of these yokes is just shy of 26,000 Australian dollars, where to repair them, it was nowhere near that. But now we're going to get them strapped, spray on a rust preventative agent, wrap them up and get them back to our customer, which is only just up the road. But after that, they have another 10-hour drive to get to the mine site where the D11's parked. But that's it for this video. Thanks for watching. So these are the main pivot. So the yokes are the main pivot point.
What the hell?
Point. So the yokes are the main pivot point that. Oh my God.
What? I'm gonna.
To do the crack testing, we're going to be using our Magnaflux metal particle texture. So now that we know that both.
Can you not say so?
Right. So to set it up, I'm going to putty. So now with that done.
Just now, not so.
So I've taken our measurement. So I've taken my measurement and we've got 0.15 of a mil to. Oh, fuck off. Right. Now our second one's prepped. Oh, fuck. Now our second. Oh my God. Now our second one's prepped. Now our second one's prepped and the first one has cooled down. We are going to swap. Oh.
Please. Whoa, what the hell?
I have room. That's heaps.
In your big extension. In your extension holder. No? It's not this, is it?
That's it.